Good everyone, and so I welcome everyone on this session. This is the session 4 of Bake series, and today we will be discussing on digital energy management. And it's a pleasure to have Mr. Sriram from TCS here. He will be discussing on how the digital energy management can bring value to the business and what are its features, and I think and the details and why an organization should have it. I think in these tough times, I think every organization is trying to reduce cost, and energy cost in case of process industry is one of the significant cost. For keeping that in mind, I think it will be an important session. I request Ashmita to introduce Sriram and then hand over the session to Sriram. I request everyone to keep their mics mute. We will have a question answer session towards the end of the.
Thank
over to you, Ashmita.
Yeah, thank you, sir. Very good morning to everyone. I am Asmita and I welcome you all on behalf of JMA. Today we are privileged to have Mr. Sriram Krishnan with us. Mr. Krishnan has about 30 years of experience in power system operations and IT industry. He is a subject matter expert in energy management and has successfully led implementation of digital energy management solutions in large buildings, retail stores, and manufacturing processes. He has been with Tata Consultancy Services since 1999, and has been in various roles including heading business operations, relationship management, and delivery. He also has expertise in grid operations and supervisory control and data acquisition systems. From his earlier experience in power utility and has managed large AMS and SCADA implementations for the southern grid of India. Mr. Krishnan is currently part of the Internet of Things business unit of TCS as an industry advisor. Today, Mr. Krishnan will speak about digital energy management. The session will continue for about 70 minutes, followed by a 20-minute of Q&A. With this, I welcome Mr. Krishnan. Over to you, sir. Thank you.
Hello, can you hear me, Asmita and Amita?
Yes, sir. Loud and clear.
Very good. Thank you very much, Amitabh, and thank you very much, Asmita, for the brief introduction. In the COVID days and everybody sitting at home, it actually is a very good opportunity for me, and also it's a pleasure to connect to you all in the Jamshedpur Management Association. So very good morning to the ladies and gentlemen. I will be talking about the digital energy management today. I think Asmita gave a brief introduction about me. Yes, I have got about 30 years of experience and quite some in energy management as well. Of course, I have not learned whatever has been said, but I am striving towards that. Let me share some of my experiences I had in the area of energy management in particular, and how it affects the industry and what is the business potential as I take you through the slides now. Do we have to turn the camera on, or should I just share the screens, Smita? That's okay?
So you can just share the screen.
Okay. You can see it now?
Yes.
Thank you very much. So what I intend to talk about today is these 4 topics in general. Energy management is not something new. We may talk about digital energy management today, but energy management has been there for quite long times. Every industry has to look at energy management in particular. There would have been audits year on year in every manufacturing process. But the awareness has spread a lot now with the introduction of renewable energy, and also the fact that people are more aware about the fossil fuel usage and the efforts to reduce it, and also to conserve energy in different aspects of life, not just manufacturing. If you look at the buildings, if you look at the transportation as well, not just electricity, energy in any form. So it has become a very critical aspect of day-to-day life in terms of how we conserve energy, because we know there is only limited amount available in the future. So I will take you through the concepts of energy management, and I will also talk you through the digital energy management more from the perspective of what we have in TCS, and also how in a digital way it impacts the businesses, and of course the saving potential what we have in the future.
Here's what I found online.
Sorry about that, was my phone. So I hope that you see the screen while I don't, but I can talk about it a little bit on the. How do I hide this poor part of the screen which is on the right, Smita's? Okay, I can move around.
Okay.
Yeah, I got it. Okay. So the fact, if you know that the buildings during their lifetime, from the time of construction to the time they spend, about every building lives for quite a many number of years, minimum number of 20 years. Some live up to 40, 50 years as well, some 100 years as well. But the way the buildings are today, the way the amount of energy it consumes, it actually consumes 40% of the world's energy, which also means that they emit 1/3 of the greenhouse gases to the atmosphere, and they have a very severe impact on the ecology technically. And of course, we all know about the manufacturing process. We always used to think that manufacturing consumes a lot of energy and manufacturing actually emits a lot of greenhouse gases, which is also true. But compared to the buildings across the world, because of the sheer quantities and sizes of it, buildings also do emit a lot of energy, which means that these two are very critical when it comes to the energy management. When I talk about buildings, I don't only talk about the houses, the office buildings. It is also the retail stores, the malls, and the buildings inside the manufacturing facilities as well, any type of building for that reason. And if you look at it, even today, for whatever effort that has gone in, 70 to 80% of the energy sources are fossils, and they are very carbon intensive. Any expectation to reduce further by the year 2030, 40, 50, there are goals, but our progress has been very slow, while it has picked up in the recent past. But of course, if you look at the enterprises today are not working in silos. Enterprises today are connected. They have operations across the globe or across the continent or across the country in different places, which means that they need to understand how the different operations are working, the different sites at different countries or different geographies are working. What is that they contribute towards the carbon emission goals? And also the fact that they need to have a system that understands all this and suggests in a proactive way, provides insights in such a way that they can march towards achieving their goals in terms of the sustainability and in terms of the carbon emissions, and also in terms of saving potential for themselves. As you spend less in energy, you also make money out of it. So what are the drivers, if you look at it, in terms of why do we need to have a digital energy management solution rather, right? If you look at it, as I said, that many of the companies have a global presence or a countrywide presence. And also, if you look at the retail stores, they have chains that operate across the globe or chains that operate across the country or a state, which means that they need to have some kind of real-time visibility, which cannot be provided by certain systems which are working in silos or a very smaller systems that connect to the meters or something like that directly and produces some graphs and charts and Excel sheets, right? So they need to have a comprehensive system that's going to give them a visibility, and also it's going to provide them a lot of analytics in terms of what can happen in terms of benefits or resolving issues. It should be reliable because most of them operate, be it the refrigeration in a retail industry or the manufacturing process. If you look at the steel manufacturing itself, if we talk about Jamshedpur, which is one of the core main business, it's a very energy intensive process, one of the highest in the world in terms of the energy consumption, which would mean that they need to have their equipments running very well. So it's not just energy, equipment which is not at its prime or which is not operating efficiently would mean that it's also consuming a lot of energy, which we don't want that to happen. Not only from the perspective of energy, but also from the fact that we don't want the failure of the particular asset, which is very critical. And across the world, regulation is driving. Every country has goals. India has a lot of goals in terms of green energy. India has got a lot of goals in terms of. Is there a question or something? Or okay. A lot of regulations coming in from across. I guess I'm okay.
Yes, sir.
Right. Okay. So across the globe, there is a target by 2025, 2020 is gone. And I think that most of the countries have achieved to some extent the targets requested. By 2030, in terms of how much has been the energy consumption, how much reduction has to happen. Every company has a goal in terms of cutting it down by 20 or 30%, which is substantial. From a 2010 baseline, for example, in Europe and in the US, most of the companies and the enterprises are expected to cut it by 20% by the year 2030. It is substantial. This despite they are going to grow as well. And cost has been always a factor. As we go forward, the cost of energy has been increasing on day-on-day basis, which would mean that saving energy also gives some money in the pocket for the companies to operate and focus on certain things which is more critical. So how does the market show? If you look at it, this analysis is from the Technavio analyst. You can see for yourself that the growth has been significant. By market itself, energy management by itself is a $54 billion market today in the year 2020. Though the one I am showing is not a fact, it's a fact until 2019. This is a 2019-20 data. So I think 2020 is still to go. So it's expected to reach $54 billion by the end of this year, which by itself is more than a 20% growth rate for the year. It's very substantial. The budgets are there. Every enterprise, every business, every company is putting money in it. Not just because they have a sustainability goal, not just because it gives them money in the pocket. It's also a responsibility towards the ecology, towards the ecosystem, to make this planet a better planet to live, because end of the day, it gives you back. So it's every business is focusing on that. And if you look at from where which business or which part of the geography is investing, you can see it for yourself. Actually, the US and EMEA is also equally sharing with 35 and 37%. But the fact is, if you look at the energy consumption, even if you look at electricity consumption alone, India is the third largest electricity consumer in the world. If you look at it, the first one is China, which consumes about 6,000 terawatt hour of energy every year. India does about 1.5 terawatts, 1,500 terawatt hour energy of electricity every year. It's not very close to China, but still it's a third, which is quite substantial. So there is a lot of spend in India as well in terms of cutting down the energy cost. And which one is giving business? If you look at buildings, there is a 7.5 billion budget in building energy management system itself. Industrial energy management, which has been always the focus, while buildings, the awareness has picked up in the recent past that they also consume a lot of energy, and there's a reason why we should put some measures to control it. Manufacturing has been always a process that is looking at how to cut down the energy cost, right? Right from, and of course, you guys, most of you guys, I would guess that the audience today is apart from the businesses in Jamshedpur, and also some students as well. I'm talking more to cover both the audiences. So from a business standpoint, if you look at it, manufacturing and buildings are the most important things to focus. Because they consume most of the energy today. And if you look at the rest of the things, it's a substantial part, but it's not necessary that we don't focus that. But the fact is, you make a lot of benefits, or you make a lot of progress by focusing on cutting down the building energy management, cutting down the building energy cost, and as well as industrial energy or the manufacturing cost, energy cost. So who are all the players? There are players like us, like TCS. We focus more in terms of services as well, which means that we just don't. This is not, of course, I don't want this to be a TCS presentation. I have made this presentation very generic, but I do have to touch upon some way we operate. TCS as such, we provide services like any other IT services companies. There are quite many people like us. Similarly, there are people who are very hardware specific. For example, there are a lot of OEMs, for example. Okay. The original equipment manufacturers who provide you hardware in terms of how to make the performance of certain assets better. Is it such only a noise, or I am hearing, or is it somebody?
Sir, it's some background noise.
Okay, sorry. I request if somebody is not on mute, if you can look at your desktop or laptop, you can see that. So the hardware components are something like somebody comes and changes some of your equipments. For example, if it's an assembly line, some components of the assembly lines can be changed. If it is a building, for example, which has a lot of air conditioning, some compressed components can be made or made more efficient with from 2-star to 5-star energy rating or something like that. So there are a lot of hardware businesses also involved in this, and of course, a lot of equipments that they are going to supply as part of the software in an IoT world. For example, there are edge devices which is going to communicate with the sensors and all, and of course the sensors as well, which also comes in the hardware category. If you look at software, there are people who just provide software like the energy management solution and systems, which provide you can install and run it, which provides you reports on a day-on-day basis. So the industry is for all. There are large players in terms of the IT service providers, in terms of the original equipment manufacturers, but also there are a lot of startups in the business who bring in value in terms of smaller programs, focused programs, and niche programs that look at cutting down the energy cost of certain sector or components of the business. For example, there is some energy aware or power quality aware modules that are available in the market, which you plug into your, for example, your refrigeration or to your washing machines or something like that, which can also be controlled by Alexa and all. They understand the fluctuations in energy, they understand the frequency, they plan it in such a way that they run your equipments when the power quality and the frequency is higher, so that the load goes when there is low load hours, compared to the frequency when it is when it is lower, where you do not want to put the machines on, just because to help the grid in a better way. So there are a lot of types of solutions available, but primarily the focus has been on there is a component in the industry called the ESCO, which is called as energy services companies, which provide services using software. So most of the business lies between the services companies and the software companies. So now I will come to the digital energy management. I will cover a few aspects of it in terms of the building blocks of an energy management solution, as I touch upon the benefits of it as well. When you speak about digital energy management, it obviously means that you have to bring in certain digital technologies, right? And why do we need digital technology? Why don't we just live with whatever we had before? Obviously, it's a question everybody will ask. For example, meters have been always communicating. It's not necessary that today's only because we started talking about digital, the meters have also become digital. The meters have been digital for a long, long time, technically, right? But there has never been a system that allows all kind of information, not just your energy consumption data, but also the load data, the performance data, the ambience data, coming into one platform that allow scaling of this analytics in such a way that you understand the potentials of savings and the benefits in a much better way. So the digital energy management solutions primarily provide this as a platform. So you have if you go from bottom to top, you have devices and sensors in different ways. You of course have smart meters. Smart meters communicate in different communication languages, right from RS-485, which is the basic one, which is Modbus one, to the LoRa and the Wi-Fi and Bluetooth technologies, right? They can communicate in many ways. Of course, they are also priced differently also based on it. If you go to the industrial sides, the PLCs have been there always. There's a SCADA system that have been always there. The plant DB system in terms of the historians were always there. You can allow these kind of systems which have been legacy, and also the sensors that have come in new in terms of understanding and communicate over the internet directly. For example, a temperature sensor can communicate over the internet directly to provide you the information, or you can get it from an RSS feed also. So they form the fundamental platform for providing you the data into the systems, and there are different ways of communication. If you go to the next slide, there are two sets of communication. One is that the sensors communicate to a concentrator or something, and then the concentrator communicates back to a system that's going to be sitting in some control rooms, right? Your 3G, 4G and all is something that the concentrator, which we call it as edge in the IoT terminology, that communicates to the control room or your servers or a cloud or something like that. Whereas on the other side is different sensor communication systems or communication boards like the LoRa or the Zigbee or the Wi-Fi or a Bluetooth kind of things. The backnet is very specific to a building automation systems communication model, which also forms part of the whole ecosystem. Do we need to have cloud, or can we keep it inside our offices and the building so that we don't get exposed to the external world, so that it is secure? Is a question most of the people ask. But today's the cloud technology is also improving in such a way that it can provide you security on the internet. And in today's COVID world or the post-COVID situation, we all know that most of us are going to work from home for quite some time, which means that obviously the businesses that are moved to cloud are the businesses that can expose their enterprise systems on the web in some way as gained an advantage compared to others, which means that cloud has come to stay, and cloud gives us an enormous benefit in terms of accessing from anywhere once you have your privileges and you are secure, right? So of course you can put it on a cloud or you can put it on a machine on your office, it's up to you. But today's digital energy management solutions provide all the options, while cloud has come to stay. So now you have cloud, which provides you resources like your storage components, like your processors, or the virtual machines or the computers virtually hosted in the cloud to allow you to configure your solution. But you should also have some services in terms of the web services or something like that, which allows you to communicate to the cloud, which provides you consistency, integrity, security, etc. And also it provides you a platform that can keep evolving as the future evolves and demands certain changes to the requirement. So the IoT platform is something also which has come to stay, which is evolving, which has gone miles in terms of what it can do, right? It allows you to connect to different devices, speak different languages, collect information, and collaborate in such a way that with other systems in such a way that it is seamless. Of course, since so much of big data is coming in, right? Your smart meters are, if you are configured to send data every 15 minutes or every 1 minute or every 10 minutes, whichever way you want to compute them, there are thousands of them in there. There are process-related data, there is temperature-related data, there is occupancy-related data, etc., from the buildings that comes in. Then you have a lot of data that is coming in, which would mean that you need to have some ways of handling this analytics, which is primarily we focus on machine learning because it provides us intelligence and step up to artificial intelligence as well in the future. So we primarily bases the analytics on big data analytics by recognizing patterns which are known and which are hidden and detecting anomalies. All these components can help you from a business standpoint for companies like us to provide energy management as a service, so that an automotive company or a steel manufacturing company or a chemical manufacturing company, which all are there in Jamshedpur, or the cement manufacturing or anything else like that, do not worry about their energy management. They can completely kind of offshore it to a service provider who can work on a kind of a energy savings contract or energy savings model in such a way that the benefits are shared. Quickly into what a solution will look like. Because it's a digital system, because it's if you look at the way your smart meters talk different languages. For example, if they talk over a Modbus protocol, I don't know how much of you are technical. I will restrict the technical language a little bit, but still there are certain reasons I have to use it. Forgive me if it's a little out with today's presentation, but generally to understand, not everybody speaks the same language, right? So you need to have a digital energy management solution that can understand the different languages that come from different sources. For example, as you see in the left, the manufacturing facilities, the buildings, the windmills, and all those things, having different kinds of information transmitted in different way. You should have an ability to sense that data that's going to pump in, right? It's going to be millions of data points coming in every day, right? If you look at an enterprise. Allow you to provide dashboards, slice and dice data. Honestly, many of the information in the beginning, if you just put a dashboard, you will see that there is a problem. It's not necessary for you to someone come and do an analytics and tell you that what's happening. You can see that the buildings of same size, one building is consuming more, one building is consuming less, which obviously if you look at the dashboards and the reports, you can see that. It provides you those basic facilities. Analytics is what is going to give us the edge generally. If you look at all the businesses across the world, even if you look at today's COVID situation also, if you look at what the reports that are coming in, the flattening of the curve, how the economy is going to bounce back, whether it's going to be V-shaped one or a U-shaped one, what is the data telling us? Though I think that the data are even in terms of the recovery of the patients, etc. It's all about data and what patterns you understand from the data and how we can, from the data, how we can project the future. So machine learning has become very critical aspect in any aspect of the business to understand the performance and provide predictions and provide insights in such a way that the business can benefit. The system also allows you to respond back. It's a real-time system in most of the cases we have implemented. And also because as the data gets mature, more and more data comes in, right? It allows the models to be retrained, the machine learning algorithms to be retrained. So it provides you the dashboards. It provides you the analytic foundation based on which you can derive insight from the data, right? It provides you prescription for the operations, etc., or for the future or the forecasting. And also it provides you alerts in time to take actions, right? We always know that in an engineering system, there are alarms, right? Alarms generally come in when there is a fault or when there is a likely fault as an annunciation. But there's a slight difference when we talk about alerts. Alerts are mostly insights and intelligence. It says that, hey, look at it. You could have slightly changed the oxygen pumping into the system in a different way. So you would have saved this much, but still you would have produced the same result. Those can, because you have done it before in the past, like these kind of instances. Such a kind of intelligence, right? Or you say that for the current ambient temperature, it's not necessary for you to pump in so much of chilled water into the chiller, right? So those kind of things can come in. Those are the alerts and insights that allows us to reduce the consumption of energy on cut-based stages, right? And as I said that it can be a closed loop system, so that if you want to automate automatically to change the set points of the operation, you can still do it. So it has to be mature in that way, right? I'm not going to talk too much in this particular slide. It's highly technical, but I just want to cover a little bit. If you look at it, there are machines which can talk in a language that most of the industries today understand, right? The controllers have become more generic. The controllers, there are still legacy controllers in the market, but there are generic controllers also available that can provide you data back in a structured format, right? What you see there is a chiller, there are air handling unit, and there's a motor and a pump and a compressor there. There are data centers, etc. So in terms of data sources, the platform should allow you access to all kind of data sources and understand and to be able to pick up the information and format it and structure it in such a way that the analytical engine in your IoT platform can understand it. There are different type of protocols available in the market I spoke about. And just to probably the message I want to give from the slide is, like any system, you need to have a machine at the site, which we call it as edge in the IoT terminologies. Or if you go to a SCADA world, it is a remote terminal unit that's going to be sitting on the site and going to concentrate the data and send across to the storages or the cloud or the in-house machines where the IoT microservices will be running. Right? The services, when I talk about the microservices, that will be a service that can understand only the information about the devices. There is a service that can understand and queue the data to the different application that's going to host. There can be services that can actually interface with ERP systems and other systems from where it can exchange data. So, of course, Edge is going to be a little bit more intelligent than the RTUs, because RTUs, we call it as dump machines because they don't have any intelligence by themselves. But Edge can have its own analytics as well, so that not every data has to be pumped to the central servers. Edge can take decisions by itself. So a little bit on the data sciences, the first principles of DCMs, how we are using it. So without going much too detailed into it, machine learning, artificial intelligence, deep learning, these are all the terminologies you might have come across in different fields, right? These are all how we can allow the machines to understand data, provide us insights, improvise on it to act automatically, and provide insights even at a later point in time, even we would not have thought about. It is artificial intelligence as well. And in case if the data is too much and too complex, how we allow the deep learning to understand it and provide us insights as well. So these are different stages. We use it for different purposes. So, but data science has come to stay, right? If you look at it, there are three types of data sciences principles or the patterns we will do. One is that when the data that comes in has, we don't know what pattern it has, for example. Normally, the data sciences we used to use it for three reasons: to understand the hidden patterns. Number two, if the pattern is known to us in the beginning itself, in the sense that, for example, the pattern of an energy consumption of a manufacturing process, it's a known pattern. Then how do we actually use it to forecast, or from the data, what kind of anomalies that can exist? Which will be in a kind of an outlier or a change from the crowd or something like that. This is an anomaly, right? So these are the main three reasons in an energy management solution or a digital energy management solution why we will use data science. And there are different types of mathematical models and statistical models which we can use. Some of the names you are seeing there are some of them, but generally they come under three major categories. One is that the unsupervised ones. Second one is the supervised ones, and the third one we call it as the reinforced ones, right? So the unsupervised ones is something where we don't know the pattern. For example, there is a manufacturing process. At some point in time, there is a problem in terms of its efficiencies. It may not be because any of the particular process parameters have been changed. It could have been because some of the things that have happened in the pre-process of the manufacturing thing of that particular product could have changed something, right? There could have been hidden patterns, or in the case of a building, for example, a particular chiller performs when there's a particular surge in the input electrical current. We would not have noticed it, but the patterns, once we recognize it, can tell us these kind of things. This is unsupervised. We don't train it in such a way that this should be the pattern of the results. It just provides us the information by itself, right? Then the supervised one, where we say that normally this is the pattern, then what's going to happen in the future? When, for example, every day I consume so much of energy, every half-hour interval, this is the data. This is a time series graph, right? And this time series graph, if I project it for next month, next year, what is going to be the consumption? That's the supervised one. And the reinforced one is something like you feedback whatever output is coming out back to the algorithm in such a way that it understands and corrects its forecasting or the prediction methods, right? So using these kind of algorithms, we can provide set points and prescriptions for operations. For example, I can tell what should be the amount of water and the temperature of the water that the chiller has to pump out, so that the environment is set at 25 degrees centigrade tomorrow, despite the ambient conditions of 35 or 40 degrees centigrade outside and hundreds and thousands of people coming in, right? I can give set points for the operations of, for example, a blast furnace or a particular assembly line or a paint shop or whatever it is in a automotive industries for the different equipments to operate, right? Or I can provide forecasts in terms of, for example, most of us are in energy. We buy energy on a day-on-day basis. Today, India market is more like a day ahead market, which means that you can forecast your energy use for every 15 minutes the previous day. The companies can do it in certain parts of the country and tell them this is my forecasted energy for tomorrow. Every 15 minutes is my requirement, right? And I can buy it probably at 80% of the normal cost, which means that I save directly 20% there, right? So when you can do that, such a forecast needs high level of accuracy, because if you are not going to use that energy, the utility has still sold it to you, so it's a waste, right? So those kind of forecasts and all those kind of data, just with the shared data, you can do it. So machine learning algorithms and data science principles provide you insights, provide you these kind of prescriptions and forecasts, and Anomaly detection, a slight change, for example, in a crowd, this point stands apart. For example, of all the air handling units, this particular zone has a lower temperature, while it is all connected to the same chiller. Then you have to go and investigate what is the problem. So those kind of things the data science can provide you, and data science by itself can help us cut the energy cost by 10 to 15% actually on a day-on-day basis. So one is on the left side, you see the data science principle. On the right side, you see the engineering concepts technically, right? The engineering, if you look at it, I've taken the chiller plant example here. There is a cooling tower circuit, there is a chiller circuit, and then there's an air handling circuit, which is the output where the air gets pumped in, right? If you want to model this in the engineering concepts, right? If you want to model this by the length and sizes of the ducts, the capacity of the condenser pumps, you provide the input and output, you can understand the efficiencies of the system. Most of the companies that come and install HVAC systems in your facility, they use this actually to understand the flow. But it is kind of a one-time. It helps a lot in design. It helps to assess the current operating conditions, but it's not that intelligent to provide you insights about where is the problem is actually happening, right? In anomalies, which actually will not see as an engineering fault, but there's an opportunity to see. So we have a combination of both to understand and help us understand the places where we can improve our energy usage, where we can optimize, where we can cut wastages, and how the business can benefit from all this. So in my opinion, the value differentiation is, while technology provides you the platform to assimilate all type of information to collect, collaborate, and also analyze in different ways, vertically, horizontally, and whichever way to make results out of it. It has to be a combination of engineering principles, which we call it as the first principles, and the data science principles, which actually works in a different way, that it doesn't really kind of apply those engineering concepts in the first line itself, but it does understand it as a data, unbiased, and provides you insights about what are the anomalies in the data, what is the structure of the data, what is the pattern of the data, so that you can make decisions. Right? It has to be a combination of everything that provides more insights to the businesses about how they can operate their particular line of business, maybe it a facility or a manufacturing process. So before I go into the slide, probably I can talk generally about where all the opportunities happen, right? We see, first of all, if you look at manufacturing, there are key, we call them as the key cost centers for energy. There are about 6 businesses which are important, which is the metals industry, the mining industry, the chemical industry, we call them as distribution centers, that's the right word probably. And then you have the metals and mines, chemical, you have the cement industry, you have the textile industry, right? These are very high consuming, energy consuming businesses. There is plenty of opportunities in there everywhere for us to look at and reduce it. And everybody says from the way in today's operation, there is about 30% possibility for reduction. If you look at automotives, paint shops by themselves are a huge energy mongers. Everybody knows it. And we can look at obviously ways of cutting it down by 15 to 20%. And if you leave the manufacturing alone, come back to the other side of the world. If you look at retail industry, for example, the groceries in particular, they spend millions of dollars in energy costs only for air conditioning and refrigeration, because they have a lot of cold storages. They have large malls which are fully air conditioned, and it means that there is quite an amount of opportunity, because there is fluctuation in load that's going to be happening inside the malls and the supermarkets and inside the refrigeration. For example, they don't stock the refrigeration full all the time. There are not always a million of people inside the mall, right? So which means that data science pitches in here to understand the fluctuations and the pattern, if it can recognize from it, and it tells you that what should be the way you should be operating this air conditioning units in the malls at different times, right? It gives you set points for it, right? You don't keep 25 degrees centigrade now, you rather keep it 26 degrees centigrade, but you adjust the flow in such a way because it's heat transfer. The chilling you feel inside an environment is it's a multiplication of the volume of water that's going to, the chiller is going to pump out and the temperature of it, so that it gets discharged to the air, right? So if you do it that way, there are quite a many options you can have in terms of how we can control your energy costs in a particular when it comes to the mall. Similarly, the refrigeration temperatures it doesn't allow, but it can you don't normally set there are different zones in a refrigeration at 4 degrees centigrade, minor 4 degrees centigrade, or 20 degrees centigrade, which you normally don't touch because it's important. Whatever be the quantity of food that's inside, still the temperature is maintained. But it is also important that they don't fail, right? If it's going to fail, if there is a problem in the refrigeration, it means that there's going to be food wastages. So you can look at both the patterns of it and say that what should be the right set points for the different operations. So there are many ways we can understand how energy can be saved. These are a few examples. Again, if you look at the in a manufacturing process, there are gases involved. There is we call the manufacturing side of energy management as gauges, which stands for water, air, gas, electricity, and steam. Whereas if you like come to the buildings, it's primarily electricity. If you go to the western side of the world, it is for heating. They use a lot of gas as well. So it's not much. Water is not something they are bothered about because they consume very less of water as a building. But enterprises do it more. So it's all water, air, and electricity there. But if you come to the manufacturing process, there are a lot of other energy sources that are being used. You also use coal directly, right? So we normally call it as wages: water, air, gas, electricity, and steam. And if you look at the way here, the way you have to look at it is you will not be looking at it in silos as electricity or gas or something separately. You have to look at them together to understand the performance. Limiting the gas can limit the use of electricity also. Reducing the pressure of air can reduce the amount of electricity also. So there is kind of combination of things that you can understand. A digital energy management system that's going to be based on data science and also use first principles such as digital twin, right? To reduce the usage, to understand the performance or simulate the performance, how beneficial it's going to be, can provide you lots of insights how you can cut down your energy use. So again, coming back to the example of the building, right? If you look at the HVAC, we provide the opportunities are like providing the scheduling for it, because if you look at a facility, there will be about 10 and 20 or 5 or 6, even quite a many number of chillers and air handling units that will be in operation. You can tell them a schedule about what time and which one has to run, etc. from a scheduling perspective, which is more efficient. You can also provide dynamically control and manage these equipments in such a way that it takes into consideration the change in the patterns of load on it, being the number of people inside a room or the heat load in a manufacturing process. Of course, lighting is more on the hardware side. If you convert most of your existing lighting into an LED, it means that you save quite a substantial amount of it. But also, if you can allow the natural light to come in, and if you can look at reducing your lighting needs based on it, such a kind of opportunity, an energy management solution. In fact, there are solutions which can also control the operations of the blinds, which means that it can control the amount of light that can come in. Such a solution is quite possible. Refrigeration, as I said, it can a centralized usage of all refrigeration systems to understand the performance be quite beneficial. But if you look at these on the load side, if you come to the trading part, just by forecasting your energy correctly, and in many places in the countries, I think from India, it is just because of the COVID issue, it has been stopped. But India is also going to allow a real-time trading for large enterprises, at least, to start with, which means that at different time of the day you have energy available, and if you are intelligent enough to use it, you can pick it up at a very much lower price, right? Which means that you need to have a system that's going to predict how much exactly is going to be your energy need, how much you can do it from the contracts you already have and the systems or the captive generation you already have, and how much you want to procure at a particular time of the day. 1 hour in advance, if you can make a prediction like that, you can probably get it at 30-40% cheaper. It's more an availability based tariff kind of concept that's going to come. And it is existing in most of the Western world as well as today. Benchmarking and baselining is important because any digital energy management should allow you to, so how much you have saved. So I have been using this digital energy management for the last 1 year. So how do I say that I have saved so much? Because last year I might have then produced probably 1 million tons of certain goods. This year probably I've done 1.1 million tons of goods. Probably I've consumed the same amount of electricity, but there could be a reason that it's not because of the system, but it could have been because of the quality of the raw material that has come in, right? So an intelligent system should not only tell you that against a bill I have saved you this much, because I don't think it's true reflection, because there are so many things that change in an operation, all cannot be attributed to this. You should also understand that under what conditions you produced 1 million ton for X kilowatt hour energy usage last year, to comparing against the same operating conditions or the different operating conditions this year, and you have produced a higher or lower quantities, but for a higher or lower energy consumption. If you baseline it, and if you can compare it, what exactly is your save? So that's what the solution provides in terms of baselining. And in terms of benchmarking, it allows you to compare it against the rest of the industry. This being a common platform to everybody. Everybody can, we will be able to understand the performance of the different industries and tell you where exactly your organization stands. And because it understands the operation of the different equipments and assets, it can provide you a lot of insights into how your assets are performing, whether they require any retrofit, right? So before I again go into this, energy management has to be comprehensive. I told you, I'll go back to the previous slide. There is a data science concept, there is a technology concept, there is an engineering concept. You may, for example, if we take the example of a blast furnace, if you understand the energy performance is low, you may not only try to tune the efficiencies of your processes, you may also tune the efficiencies of the systems, which means that you may have to do some changes to the hardware configuration. The energy management solution should tell you that what kind of engineering changes you have to do. If it comes to the home, should you change your compressor, or should you reduce or increase the size of your ducts? Those concepts it should provide. So it's from an engineering perspective, it should still provide a lot of insights into that to you in terms of what changes or configuration changes or engineering changes, component changes you have to do to the system. And it also should help you on a day-on-day basis to conserve energy more and more, which the data science can drive. And if you look at it, it has to be comprehensive, it has to be holistic, and it should drive you towards your objective of how much your 2020 or 2030 goals in such a way that it reduces your cost progressively. So what we think that we can save, the different businesses can, this of course can be different for different businesses. In terms of how you measure, if you just put a monitoring and visualization dashboard thing, probably you might start saving something, but it still not be comprehensive. If you put some asset performance monitoring, if you look at the manufacturing industry in particular, or even for the purpose heavy equipments inside a building, right? There are two ways we can look at it, how we can save the energy. One is that the performance of the assets themselves, whether they are performing in the prime, or the performance of the process. When all these assets come together, whether they perform efficiently, whether there's a need, though a particular pump or motor is running at 99% efficiencies, or 100% efficiencies to be, though it may not be possible, is it still needed to run at that set point, right? So it has to be both. So when you start looking at the asset performance in such a way, using technologies such as digital twin is nothing but it creates, I think I failed to mention that, it is a kind of a replica of your original system. If it's a blast furnace, if you can capture all the parameters of the blast furnace, if you can create it, the system that's going, the model that's going to be running on your computer should be able to simulate what is happening in the blast furnace. Similarly, it should be able to simulate what is happening in the HVAC circuits, right? If you can have those kind of digital twins, it can help to improve it further. The data science principle will look at it on a day-on-day basis and it's not just something, it's a continual improvement. That's what ISO 50001 also warrants. It's not that they can do an audit today and be happy with it that you have made some changes to the system and you have made an improvement from X to Y. It says that you have to do it on a day-on-day basis. That's how you will reach your targets for 2020 and 2030. So it's going to tell you that. So machine learning services will going to add on to whatever you have been doing so far in terms of your changes to your retrofits, etc., etc. And eventually, once you have the confidence, you can allow it to automate and switching on and switching off or changing certain set parameters of a particular equipment so that you derive your savings from that. So you can achieve a goal of 10 to 30% quite possibly. It's going to depend on how we are going to integrate it, how the system is going, how holistic the system is going to be. So, but what I think will be the future is this. I don't think that energy management can work in silos. Energy management is part of a building or part of a manufacturing process by itself, right? You cannot compromise on a process efficiency or an output quality just because you want to save energy. And if you look at the building alone building may have a security system, building may have a safety systems, building may have other processes which requires energy. You cannot cut down energy for it. And similarly, if you look at it, the progress is something like smart energy, smart facility, and then the smart cities and all those things coming in one by one. It has to be part of that whole ecosystem to understand its role in it. First of all, if a digital energy management system, if it's going to work in silos, and of course you are going to trade energy with different people. If you look at it in tomorrow's world, people are going to come in and say, declare availability of their energy. A wind farm might supply energy directly to you at a cheaper cost than going through the distribution company. Right? That's the kind of system we want to. We want to democratize the whole system tomorrow. The utilities operation, as we see today, is not going to be the same tomorrow, definitely, because all the utilities are going to be more like an agents, and they are not going to be the people who are going to supply energy to you directly, but it's going to be more that the businesses, and even to some countries, even the homeowners can decide from where they want to purchase energy. And the homeowners and the businesses themselves are going to generate energy within themselves. Tata Steel does that in Jamshedpur, I know. Not many industries do, but most of them have their own captive sets. Most of them at low load hours can pump in this energy to the grid. But when the power comes to the grid, it doesn't mean that you are pumping it to the grid at a time when the grid doesn't want it to, right? So you need to have a comprehensive system that's going to understand all aspects of it and take a call in terms of when to generate, when not to generate, when to cut down your cost, when not to cut down your cost. It's not going to work only from the perspective of a particular facility, particular manufacturing site, or a particular building by itself. It's going to look at the outside world. It's going to look at the other performance of other components and other agents inside the circuit. So you need to have a common platform or a connected platform that's going to tell you all this that's going to be happening around, so that you can take decisions in a much calculated way. So I think it has to be more comprehensive and holistic in tomorrow's world, but that I think will be the future, right? From the smart homes to smart malls and appliances to the trading you can do. Not just you may have your renewable energy and distributed energy sources, but you can buy from other renewables also. Every organization is mandated to go green. You can look at all those aspects and take business calls that's going to help you reach your targets or exceed your targets, which is going to help an organization not just with money in the pocket. It's going to help you in terms of branding the organization in such a way how it reacts to the world's needs, and generally if outside it, it's going to help the ecology. So I would rather stop here. If I hope that I could cover the details which the crowd in general would have expected, the audience in general would have expected, being the different types, and I will be open to take questions now.
Thank you, sir. So the session is open for question and answers. Participants can unmute themselves and ask the questions.
Hello, sir. This is Gaurav Anand from Jisco. Hello.
Hi, Gaurav. I can hear you.
Yeah. Thanks a lot, first of all, for such a wonderful insight on this digital energy management thing. Sir, I had a query about the LoRa smart meters. Like
Right.
prior to this, we had several smart meters which used to consume lots of electricity, which used to consume lots of data. But when LoRa came, now we can go with the low-powered and low-cost this thing networking and all. So, how do you suggest, like, how LoRa is LoRa better than other available smart technologies on meters, or still LoRa has to go a long way in that? That was my question.
Thank you, Gaurav. That's a good question as well. In fact, as a company, as TCS, we are also working with a US-based company which provides us a LoRa platform rather, and we are collaborating with them to kind of take this LoRa technology. We are having a specific team that develops the technologies for the LoRa. What I see is, I know Jisco has implemented LoRa across for the services, right? It's one of the first. It's a project which I think is about 2 or 3 years old already, correct?
Yes, sir. Yes.
So that's a wonderful thing. I think the LoRa, from a cost perspective, has come down significantly the last few years. If you create a mesh, being a long range, low power, it has its own advantage definitely, because you do not have to worry about. If you look at, for example, there are a lot of constraints when it comes to wired circuits like a modus, for example. There is a range issue in terms of kilometer. You have to wire it and all those things. LoRa has its own issues in terms of creating the mesh and all. But I think that LoRa, I would say, and there are other technologies available also. It's not just LoRa. There are Zigbees and there are a lot of other wireless technologies that are available. 5G is going to come. 5G is going to provide us a lot of other options as well. But as now, I see that LoRa is still there. It's not something. It's not. I've not seen it as a very widespread use. If I go to the Europe, I don't see much of LoRa there in many places. We have done in the UK. We have done in the in parts of the Germany also. But in the US, there is a lot of adaptability to LoRa. But I think it will stay.
Okay, sir.
If that answers the question.
Yeah. Thanks.
Technology will definitely evolve because
Yes.
I not that all types of sensors speak the same language. The standardization is still not there in the industry yet, as an IoT, as an industry, I would say. There are different types of sensors that are available, and they speak different languages and different communication models and different ways of integrating it. If there is going to be a standard that's going to evolve, I definitely think that LoRa will be one of them to be accommodated.
Thank you, sir.
Myself, Vinit from ISWPL company.
Yes, sir.
So my question is, we have in a plant, there are different devices and equipments, and we have different companies, smart sensors and devices. So during cloud selection, like there are different platforms of ABB and Siemens, and different companies are serving cloud platforms. So we should choose a single company cloud platform, or what should be the criteria of choosing cloud for a particular company? Like, it should be compatible with the smart sensors, or it should be only one company?
No, it's a good question and a difficult one also to answer. It depends on the strategy of the company, in my opinion. The way we have structured the solution in TCS, it relies less on the cloud, right? It relies only for providing some compute resources and storage. We don't actually rely on the services the cloud is going to provide us. Right? Cloud by itself can provide you a lot of microservices which can allow you to concentrate data, etc. queue it, send it to different things. Those things we take care in the platform we have, right? If you look at it that way, you can go for any cloud. It's not going to constrain you. But if you are going to be having specific requirement, if you go to a particular OEM and the OEM has a service that's being used by a particular cloud, then you will be constrained. But it is always better to have a kind of an open source architecture so that a future expansion is easier and not dependent on one particular vendor. If that answers your question.
Okay, can we have the next question, please? Sir, I think there are no more questions for us.
Okay.
With any of the participants would like to share a feedback on the session?
Hi, this is Ashmita.
Yes, sir.
So I think it is a very good session, and that has given a very good understanding how the digital things can help in conserving the energy, and the way the presentation has been given, it is highly appreciable.
Thank you very much.
Okay. Sir, I think we have come to the end of the session. Thank you very much for your time and a very insightful presentation. And thank you to all the participants for joining in and cooperating throughout the session. The session has been recorded and will be shared on YouTube channel of JMA. And to also get it through the mail, you can drop me a mail at the given mail ID. For any upcoming events, please follow Jamshedpur Management Association on social media. So thank you and see you in the next session. Have a good day.
Yeah, Ashmita, 1 second.
Yes.
Yeah, this is Amita. Yeah, just in addition to what Ashmita has said, in case anybody is interested more to understand more on the subject or want to implement in their own organization, they can reach to Sriram through Ashmita. You can drop a mail to Ashmita or myself, and we will connect you to Sriram, and he can further take it forward. I think if this is okay with you, Sriram.
Definitely, it's okay with me, Amitabh. And thanks to everybody. Thanks for giving me an opportunity to talk about it, to connect you all. Stay at home and stay safe for some more time.
Thanks, Sriram, and same to you.
Bye-bye.
Thank you. Bye, sir.